So here we're going to use our altitude to hypotenuse theorems. This is the altitude to hypotenuse. So let's consider the similar triangles. This triangle, similar to this one. Going back to this triangle, the x, the unknown we're solving for, is to this hypotenuse as this leg, the 12.8, is to the hypotenuse of this triangle, the 26.6. Now, if you don't see that, maybe you can visualize like this. See, look at that. That might help you see it. And again, the x corresponds to the 12.8. This hypotenuse, this 23, I've rotated up here. So maybe that helps you see it. But you got to get used to seeing it on the diagram. So again, x to 23 as 12.8, 26.6. Then it's just arithmetic. Well, let's use similar triangles here to solve for x. And that is, again, the altitude to hypotenuse. And we've seen, as before, x is to 8.8, the hypotenuse there. As its corresponding leg, the 10 is to this hypotenuse, 13.2. If you want to see that, again, we could, remember we've done it this way where you can visualize it again. And again, I can see it there. This becomes the 8.8, this hypotenuse, and now the x is over here. So I can see x is to 8.8 as 10 is to 13.2. Then work out the arithmetic. Roughly 6.6 feet. Let's clean up the drawing. Looks like that. This is another altitude to hypotenuse where we are using the geometric mean leg theorem. That is, we're solving for a leg of the original triangle. So, let's set it up. Oh, that's the key. You had to add these two together. Again, 5 is to x, as x is to 9. That's all you need. There you go, cross multiply, and then you can see 3 radical 5, or its decimal. Oh, and by the way, if you've forgotten, remember when you're trying to take this, or simplify that radical, remember, factor out the perfect square. It looks like that. So 3 radical 5, 6 7/10 for the decimal folks. Well, we recall the altitude to the hypotenuse is the geometric mean between these two pieces of the hypotenuse, or 12 is to 18, as 18 is to y. Set it up like that, and you could just cross multiply right there. Or if you were, say, if you're doing it in your head, you may have done this. You may have divided that out and simplified it. Then you could resolve the fraction in your head. Similar fractions or the cross product. Either way, you're going to get y equals 27. Well, let's see if we can solve now for the hypotenuse here. I've got this piece of the hypotenuse, and I've got a leg here. Again, this is the altitude to hypotenuse figure. We're going to use geometric mean, the leg theorem part of this, and we're going to say very clearly that 16 is to 27, as 27 is to my z. If I do the cross product, and I could solve that with a fraction, or if I'm decimally inclined, I would have come up like that. Easy. Now let's see if we can figure out the length of this segment, AD, given this hypotenuse 36 and this leg of ABC, which is 18. Okay, I gave you a hint in red here because this, well, this is the geometric leg theorem. This is the geometric mean between the red and the 36. So, now let's do what we have to do. We have to assign some kind of a name to this, a value. That's going to be 36 minus x. 36, take away x. This red segment is 36 minus x. 36 minus x is to 18, as 18 is to 36. Write that down. Now, before you go cross multiplying, well, why don't we just simplify that? That looks a whole lot more like 1/2. Now we can do the cross product and solve, and that should come out pretty straightforward. And it looks like this value, x, is 27.